Okay, let's talk about numbers. And you say, well, that's simple enough. I know the numbers. There are 1, 2, 3, and so on and so on. Then I get maybe to 110 and 111, but I can keep going. And that's what these dots that I'm making here, they look more like lines, don't they, signify. So all I have to do in order to generate all of these numbers is to add 1 to the previous number in the list. So I start with 1 in this case, and I add 1 and I get 2, and then I add another 1 and I get 3, and so on and so forth. And I can go on doing that, and I can never stop. There's never an end point. So there are what we call an infinite, a number of numbers. Alright, now we use numbers, as I say, to count. And we can count, for example, the number of balls in a bag. Let's draw a little bag here. We'll suppose that that's a bag. And the bag might have 0 balls in it. So 0 is a number. That's an important point to make. And then might have 1 ball in it, or it might have 2 balls in it. There we go. It might have 3 balls, or however many balls it is. And as we take the balls out, we say, hey, that's ball number 1, and then we take this ball out, and we say that's ball number 2, and we take that ball out, and we say, hey, that's balls number 3, and if there are no more balls left in the bag, then there are 3 balls in the bag before we started to take them out. So it's important to remember that 0 is a number, because it's used for counting. It turns out, in fact, that we can do a lot more interesting things with numbers if we assume that 0 is a number than if we leave 0 off. Anyway, you may have seen numbers put out on a line, what you might have heard termed a number line. My line isn't very good, is it? I'll start with 0, and then we go on to 1, and then that is 2, and that is 3, and that is 4, and so on and so forth. And those dots going on and on means that we can keep adding 1, and we can make this line as long as we want. Now, one of the things to note about a number line is that these numbers on the line are separate. They're what we call discrete. And that's a characteristic of these counting numbers. And we call these counting numbers the natural numbers. My writing is absolutely terrible, and it's difficult actually to write on one of these boards, but that's what I'm going to do. The natural numbers. So these counting numbers are what we call natural numbers, but there are other numbers. But on this number line, of course, between, let me just change color here, between the 0 and the 1, there are lots of other little points on the line. And we can ascribe numbers to them as well, and they're what we call the real numbers. But I won't go into that. There are all sorts of numbers, some things we call imaginary numbers, real numbers, and so on and so forth. But we're going to deal just with the counting numbers, which we call the natural numbers. Now, you may have seen as part of your maths class how you can, what we call, operate on numbers. You can add 2 of them together. We know that 1 plus 2 is equal to 3. Now, we need to do these operations, the operation of addition, the operation of subtraction. 2 minus 1 equals 1. The operation of multiplication, 2 times 2, 2 lots of 2, equals 4, is the same number as 4. And 4 divided by 2, how many 2's go into 4? Well, 2 2's do. So 4 divided by 2 is 2. And we perform these simple operations. Now, there are other operations we can perform on numbers, but addition, subtraction, multiplication, and division are the 4 that you're probably familiar with. Now, all of these operations and learning how to do sums and subtractions and multiplications and divisions are important. For example, so far as addition is concerned, I've got, in my left-hand pocket, I've got $1 or £1 if you happen to be in the UK, and in my right pocket, I've got plus another $2. And I want to know how much money I've got in total. I want to know whether I can afford this nice little bit of candy I've got on the shelf in front of me. So I want to know how much money I've got. I've got $1 in my left pocket, and I've got $2 in my right pocket. 1 plus 2, in this case dollars, gives us a total of $3. That's why addition is important, because you come across those sorts of problems in everyday life all of the time. Subtraction. Well, suppose I buy this piece of candy and I give $3. Okay, I give $3, but they only want to take away, because the candy only costs $2. I'll put in a $sign there. What must they give me back? If I give them $3 and the candy only costs $2, well, they must give me 3 minus 2. That gives me $1 back. So those are the kind of situations in which it's important to know how to subtract. Now, when it comes to multiplication, suppose I want to know, I've got a bit of floor, and I'll make a plan here, and I know that that floor is 2 feet in that direction, 2 feet wide, and it's 2 feet long, like that. And I've got tiles which are 1 foot by 1 foot square. How many tiles do I need? What I need to know is how many squares go into this 2 by 2. Well, there are 2 along here, so I divide that into 2, and there are 2 up here. And so I've got 2 lots of 2. How many have I got? That's multiplied. That's 2 times 2. 2 lots of 2. 1, 2, 3, 4. So I will need 4 tiles. So 2 times 2 means I need 4 tiles. And the same sort of thing might happen here. Suppose I've got a bag, and let's suppose that's full of 9 balls, 3 lots of 3. And I want to form some teams to play with these balls. And I know that each team is going to need, or each group is going to need 3 balls. Well, I've got 9 balls in total. How many teams can I make? Each will need 3 balls. How many lots of 3 balls have I got in the bag? Because that's the number of teams I can make. Well, it's 9 divided by 3, and that is equal to 3. I've got 3 lots of 3 make 9. So I can form 3 teams to play with these balls, to play this ball game. Now, when we operate on numbers, let's suppose we've got 2 times 3. We operate on these numbers 2 and 3 by multiplying them together. We always get a number. 2 times 3 is a number. What number is it? Well, it's equal to 6. It's simply the number 6. Wherever we write 6, we could also write 2 times 3, because 2 times 3 is 6. They are the same thing. It's just that it's much easier to write 6 than it is to write 2 times 3. And exactly the same is true in other situations. For example, suppose I've got a man whose name is Fred Smith. Let me just write it down here. That's a bit of a dull name, isn't it? Fred Smith. And Fred Smith is this man. He's the only one that looks like this. He's got 3 hairs, and there are his eyes, and is pretty miserable. Well, if you only had 3 hairs, I suppose you would be miserable. And let's suppose he's enormously fat. Okay, he's enormously fat. He looks pretty fat there, doesn't he? Okay, and that's his belt buckle, and his belt is really stretched around that enormous waist of his. He's got these huge hands, like that, and we'll suppose he's got enormous feet. just draw a couple of enormous feet there. Well, it doesn't really look much like a man, does it? I think it doesn't look like a man because he hasn't got any ears. Actually, he hasn't got a nose either. So I'll put a little dot for a nose in there. Boy, he looks really miserable. Anyway, that's Fred Smith. And so we can say that he is the man with 3 hairs. 1, 2, 3 on top of his head. He is very fat. He's fat. He has big hands. Big hands. And he has big feet. And he is unhappy. And I tell you, if you had all of those things, like you were fat and you had big hands and big feet, you'd be pretty unhappy, I suppose. Anyway, so Fred Smith is this man. This is the only man who has 3 hairs, who's fat, who has big hands, big feet, and is unhappy. So we could always write, when we want to say something about Fred Smith, say, oh goodness, Fred Smith's moaning again. We could say either, oh, Fred Smith's moaning again, which is the short way of doing it, or we could say it the much longer way. Oh, the man with 3 hairs who's fat and's got big hands and big feet and who's unhappy, well, is moaning again. And we'd be saying the same thing, because both of those descriptions, both of those names, as it were, fit and apply to and mark out, refer to this man, Fred Smith. And in exactly the same way, we can say that 2 times 3 is just the same as 6. Okay, it's just that 6 is a much easier way of writing a number than writing 2 times 3.